Hello everyone, in this video we are fixing a critical state constraint bug in a front-end React checkout component on Develow.com. Currently, our item quantity stepper doesn't enforce a lower boundary. A user can click the decrease button indefinitely, driving the quantity to 0 or negative numbers, which creates completely broken, nonsense line totals. We need to clamp the minimum quantity to 1, disable the button when that boundary is hit, and ensure our cart computations stay perfectly in sync. Let's look at how to approach this inside the Develow IDE using the DVL AI chat. To execute this fix cleanly, we'll turn to our DVL AI chat to locate our state management code. Mastering structural discovery using target prompts is exactly how you showcase your prompt engineering skills to interviewers on Develow. First, we ask the AI, let's find the data models. How is the current selection quantity and product price state initialized? DVL points us to a local quantity hook and a product constant. Next, we check our user interactions by asking, where are the component handlers for incrementing and decrementing the quantity? DVL directs us right to the increment and decrement callbacks inside web/src/problem.jsx. Finally, we set our guardrails by asking, what do the tests look like in test/quantity-stepper.spec.ts? The AI highlights that the suite specifically tests for a boundary clamp at 1 and expects the HTML decrease button element to receive a true disabled attribute at that exact limit. Now we can write our solution with confidence. The issue here comes down to two missing constraints in the UI component logic. First, the original state modifier blindly decrements the previous value by subtracting 1 every time it's clicked. It lacks a threshold check. Second, the UI presentation layer has a hard-coded disabled equals false property on the minus button. Our goal is to apply a defensive boundary strategy. We must mathematically prevent the state hook from saving a value lower than 1 and simultaneously lock the button in the DOM so users cannot trigger extra clicks when the quantity reaches the minimum threshold. Let's open up web/src/problem.jsx to apply our two adjustments. First, find our state handler functions. Look at how decrement is structured. The old code reads set quantity q arrow q minus 1. We'll update this updater function to use JavaScript's math.max utility. We change it to set quantity q arrow math.max 1 q minus 1. This creates a strict floor at 1. If the current quantity is 1 and a user somehow triggers a click, math.max compares 1 against 0 and safely maintains our floor at 1. Because our line total variable automatically computes downstream using product.price multiply ny quantity, keeping the quantity safe ensures our financials stay perfectly in sync. Next, scroll down to the JSX layout markup and look at the decrease button element. We find the property disabled equals false. We change this hard-coded attribute to dynamically evaluate the current state. Disable equals quantity less or equal to 1. Now the moment our quantity drops to 1, the browser native rendering engine instantly disables the button component, preventing any further interaction. With both files saved, let's bring up the integrated terminal window right here in the Develow IDE to verify our boundary conditions. We run Docker tests. The testing suite fires up headless automated interactions, attempts to click past our lower bounds, verifies the disabled state properties, and returns completely green check marks. Enforcing boundary limits and keeping structural data states mirrored in the DOM properties is an essential practice for building high-quality checkout states. By using the DVL AI chat to quickly analyze component handlers, we successfully solved this bug with minimal lines of code. This ticket is now resolved. Bye for now and see you in the next code challenge.